All right, well, hello everyone, and welcome to this review session. One of the best ways to get better at programming and study for exams is by coding on your own. So in this video, I highly recommend that you code along with me and use these practice programs to help you practice and understand arrays, pointers, and structs. If you'd like further examples and more review, I also recommend that you check out our previous lecture videos on these topics. Let's go ahead and get started. This first practice program is an example of writing a program that manipulates a one-dimensional array. So in this example, we are asked to write a program that manipulates a one-dimensional string-type array. We're asked to declare a 1D string array named FizzBuzz with num_elements elements. Here, num_elements is a global constant set to 200. Then we're asked to use a for loop to initialize each element of the FizzBuzz array following FizzBuzz rules. If we have a multiple of 3 in our index, that element should be initialized to fizz. Elements with index multiple of 5 should be initialized to buzz. And elements that have an index which is a multiple of 3 and 5 should be initialized to FizzBuzz. If an array element does not meet the above criteria, it should be initialized to contain the word nothing. After we've initialized this array, we are asked to output the contents to the screen with each element on its own line. And we need to output the number of times we outputted fizz, buzz, and FizzBuzz to the screen. We'll need to use a counting variable to help us. Actually, 3 counting variables. That way we can keep track of how many times we've outputted each of those words. Let's go ahead and try coding this example up from scratch. So I recommend that you try pausing this video and coding up this example yourself. If you get stuck, you're welcome to check out my solution. But I highly recommend that you first attempt to code this from scratch and then compare your result to mine. There's more than one way to approach this problem, so my example will not be the only way, but it's really good practice to try coding up these programs yourself to get experience. Let's go ahead and try this in CLion. Alright, so here we are inside a blank CLion project. So I'm going to go ahead and start putting in our usual headers. Here I definitely want to include my string header as well. And I'm also going to need using namespace standard. All right, so let's remind ourselves what this program needs to do. We need to declare a 1D array of string type named FizzBuzz. And here we should have num_elements elements. Here num_elements is 200. Then we need to initialize each element of FizzBuzz to the values based on our requirements. So remember, index, which is a multiple of 3 should be fizz. Any element that has index which is a multiple of 5 should be initialized to buzz. And any index which is a multiple of 3 and 5 should be initialized to fizzbuzz. Otherwise, we initialize the index to nothing, or we initialize the array element to nothing. Once we have initialized our entire array, we output the contents to the screen. And we also output the number of times that we outputted fizz, buzz, and fizzbuzz. So we'll need to use counting variables here. So let's go ahead and take this piece by piece and code up this program. So first, we need to declare our array of string type. We need to declare that constant num_elements. So I'm going to go ahead and declare num_elements as a global constant. And I've set it so that we have num_elements equals 200. To declare my string array, I can just go ahead and say string fizzbuzz with num_elements. So now I have declared this array named fizzbuzz, which is string type, and it contains num_elements, or 200 elements. Next, it's time to initialize this array. And remember, to initialize our arrays, we need to use for loops. Here, we have just a one-dimensional array, so we can initialize using a single for loop. So here we set up our for loop such that we start with our counting variable I at 0, because our array fizzbuzz starts at element 0, and we loop all the way until I reaches 199, which is our largest element, since we have 200 total. And then inside this for loop, we need to initialize each element of that fizzbuzz array based on our requirements. Here we're going to need to use if statements to help us figure out what to do with each element. So here we're going to use if statements to initialize each element based on its index I. So in this case, let's go ahead and write out our if statements. So first, if our index I is a multiple of 3, we should assign that index the value fizz. So here, to check for multiple of 3, we use modulus. So here, this if statement will capture if our element is a multiple of 3. So here, if our array element is a multiple of 3, what do? We assign that element the value fizz. What else do we need to do? we need to keep track of how many times we outputted fizz. So here, let's declare another variable. It can just be an int variable. Let's go ahead and call it numFizz. Notice here, let's go ahead and declare counting variables to count how many times we do each output. Notice if we have these counting variables, each time I output fizz, I can increment my counting variable numFizz. That will allow us to keep track of how many times we have outputted fizz to the screen. Remember, that is a requirement that our program needs to do. I'm going to go ahead and duplicate this line of code because it turns out that for our buzz case, the code is very similar. Any index in our fizzBuzz array, which is a multiple of 5, should be initialized to buzz. So in the second if statement, we can initialize all our elements that have multiples of 5. So if my element number I is a multiple of 5, again here just let's call it element number to avoid confusion with the value stored there. If our element number is a multiple of 3, we initialize it to fizz. If our element number is a multiple of 5, we initialize it to buzz. And then we increment numbuzz in this case. And let's go ahead and now capture the case where we have both fizz and buzz. Notice in order to capture this case correctly, we also need to make sure that these previous cases do not allow us to output fizz or buzz. So here I'm going to update my previous cases so that our element is a multiple of 3, but not a multiple of 5. And the second if statement will capture the case if I'm a multiple of 5 and if my element number is not a multiple of 3. That's because in these first two statements, these should only trigger if we're only a multiple of 3 and only a multiple of 5. This third case, we want to capture the case where our element number is a multiple of 5 and a multiple of 3. Then we assign that element the value fizzBuzz, and then we increment the fizzBuzz counter. Finally, our last case is to capture the situation when we're not a multiple of 3 and not a multiple of 5. So here, in this case, we are not element number I is not a multiple of 3 or 5. So in this case, we can just set fizzBuzz element I to store the value nothing. So it's just holding the word nothing there. And we don't need to increment any counting variable for nothing. So the last things our program needs to do is output the contents of our array to the screen and output how many times we outputted fizz, buzz, and fizz, buzz. I already have this for loop set up to initialize the contents of my array. So if I wanted to, I could just put a cout statement here, and this would output my value fizzbuzz to the screen after I had updated it. So this would work because we go element by element, so we would output each value to the screen after we initialize it. Alternatively, you could use a separate for loop to only contain this cout statement. Finally, our last step is to output the number of times that we had outputted fizz, buzz, and fizz, buzz. We have our counting variables already, so we just need to output them to the screen. So to get the number of fizzes, we output numfizz. To get number of buzzes, we output numbuzz. And finally, to get the number of fizz buzzes, we output numfizzbuzz. Finally, I'll just do a Control-Alt-L to format my code nicely. And we're ready to run this program. Let's go ahead and give it a run and verify whether it completed each task correctly. Just to double check, we see we have one if statement to capture when we're only a multiple of 3, second if statement to capture when we're only a multiple of 5, and we also have our third if statement to capture multiples of 3 and 5, and our last if statement that initializes each element to nothing if it meets none of the criteria. So let's go ahead and run this. And you'll notice we did indeed compile and run. And remember, we were simply initializing each element of our array to fizz, buzz, or fizzbuzz based on the element number. So element 0 was initialized to fizzbuzz because 0 is a multiple of both 3 and 5. Elements 1 and 2 had nothing happen because they are not multiples of 3 or 5. Element 3 was indeed initialized to fizz, so was element 6 and element 9. Element 5 and 10 were initialized to buzz correctly. And we see that element 15 was initialized to fizzbuzz. So our if statements were working properly. In addition, if we scroll down to the end of our program, we see that we are able to successfully determine the number of fizzes, the number of buzzes, and the number of fizz buzzes that we had outputted. So with that, we have successfully created this program, which uses a for loop and if statements to initialize our array of strings. Notice that we also needed to include cout statement in a for loop in order to output our data back to the screen. And we needed to increment counting variables in order to keep track of how many fizzes, buzzes, and fizz buzzes were outputted. Try going back through and see if you can code up this program on your own. It's really good practice. All right, let's try our next practice program. In this example, we want to play around with some arrays and functions. Here, you'll see that we have declared a two-dimensional array of double type called my2D-array. And notice that we have some code in here that will initialize that 2D array to hold some value based on the index I and j. But then we also have some functions. Notice we want to complete function definitions for sum all elements, average all elements, and print 2D array. Notice that these functions should return the sum of all the elements, the average of all the elements, or print that array to the screen. We also want to write declarations and definitions for findMax, which returns the maximum value, and makeEven, which adds 1 to any odd numbers in order to make every number in that array even. Let's go ahead and try writing these function definitions in CLion. You'll see that these definitions are fairly straightforward to write because we just need to use some for loops in order to complete these calculations element by element. All right, so here we are in our practice program. And remember, our task is to complete the function definitions for sum all elements, average all elements, and print 2D array. We also want to write new declarations and definitions for the findMax function and makeEven function. Let's start by writing the function definitions for these three functions that we have already declared. Let's first do sum all elements. Just for my own reference, I'm going to copy the entire declaration, and I'm going to refer to this as I write my function. Also remember that a function definition has the same header as this declaration, except we delete our semicolon, and we put the code our function should do inside our curly braces. So let's go ahead and write the code that we need in order to sum the elements of input 2D array. So remember, our goal here is to find the sum of the array input 2D array. So since we want to find the sum, we need to declare a summing variable. So let's go ahead and use this summing variable, sum. And in order to determine the sum of all the elements in our array, we need to use for loops to read each element and add it to the cumulative sum. So all we need to do is actually pretty straightforward. So I'll go ahead and start my for loop with our counting variable I. You can also call it row if we prefer. So notice here, I know how many rows are in my array from this value in the argument named rows. So here I'm using the rows that was passed into the argument in order to specify how many rows to loop over. Similarly, I need to also loop through my columns. And here we have that global constant calls, which tells us how many columns we have. So we can use that to help us step through our array. Now that we are inside our array, we need to add each element to the cumulative sum. So all we need to do is say sum equals sum plus input to the array element row call. This is going to go through our array element by element and add each of these elements to that variable sum. Now that we've calculated the sum, what do we need to do next? Well, remember this function is a double type function. It needs to return a double value. So at the end of the day, we need to return the calculated sum in order to finish our function. And just to be safe, I'm going to go ahead and put curly braces around both my for loops just in case we wanted to make any modifications later. So there you have it. This set of nested for loops will take a summing variable and add each element to the cumulative sum. Then we will return our sum back to our main function. So in this case, we'll be able to test this function if we go ahead and call SumAllElements. Let's go ahead and finish the rest of our function definitions first, and then we can test this out. So the next function we need to write is AverageAllElements. So in the same way as before, I'm going to copy my declaration so that I can duplicate the header. Notice for the definition, I delete that semicolon and I add curly braces so that I can calculate my average. Calculating the average is very similar to calculating the sum. So I'm going to be a little lazy. I'm going to borrow my code from SumAllElements. But we also need to count how many elements we have. So we need to use a counting variable to count the elements. So I'm going to declare another variable named int count and initialize it to 0. Remember, it's very important that you initialize these summing and counting variables before you use them. The only difference that I need to do here is I still want to calculate my cumulative sum, but I also want to increment my counting variable to count how many values we've read. So to do that, we can just say count plus plus. Now here, remember, we don't want to return the sum anymore. We want to return the average. So here, we should actually return sum divided by count. Since sum is already a double, dividing our double by an int will not produce any truncation errors. So there you have it. We have successfully determined the sum and the number of elements. So if we divide sum by number of elements, we'll get our average. The last function we need to write is print2darray. Let's go ahead and take the code and try writing this function. Like before, we take the header to match the declaration. And here, all we need to do is output the array to the screen. So in this case, we want to output the values in input to the array. to the screen. To output these values, remember we cannot just say cout input to the array. That won't work. Once again, we need to use nested for loops. We can actually use the same exact for loop that we had before. So all we need to do is go element by element and output the element at the corresponding row and column. We also, in this case, let's assume we want our elements separated by a tab. So we'll separate each element in a given row by a tab. And notice this outer for loop is going through each row and outputting the data in all the columns. After we have gone through all the columns, let's add a new line between each row of outputted data. So we just place a new line before we move to the next row. Since this is a void function, notice we do not need to return anything. The void function does not have a return type. Let's go ahead and now that we've written those function declarations and definitions, let's test out this program by running the main function. And you'll notice we were able to successfully output the initial array. Notice it's initialized to contain some values here. And notice we're able to output the sum. We see our sum is 75, and our average is 5. So far our functions are looking good. Now all that's left is to add 2 more functions. We want to write a declaration and definition for findMax, which returns a maximum value. And we want to write a declaration and definition for makeEven. MakeEven adds 1 to all odd-numbered values in the array. And so it will make all the odd numbers in our array even. Let's go ahead and write those declarations and put our preconditions and postconditions. First, we have findMax. That will need to take the input to the array as our argument. Remember, the number of rows or the value in the first element is optional. If I wanted, I could put the global constant rows there. Here I'm just leaving it empty to follow the convention in the other functions. I need to let this function know how many rows I have, so I'm going to pass in the number of rows as a second argument. So our precondition is the same as before. We have input to the array needs to be our double type array that's initialized. And here we're going to return the maximum value in input to the array. Our other function is called makeEven. It can accept the same arguments as findMax, but this will be a void type function. Because makeEven is actually not going to return anything. This function is just going to make all odd, basically adds 1 to all odd values in input to the array so that all the values in input to the array are even. Let's now write our code, first for findMax. and then we'll do make even. Okay, so remember find max. Purpose of that function is to find the maximum value in our array. The approach will be very similar because we'll need to use nested for loops once again to search through our entire array element by element. But we need to declare a variable to hold the current maximum value. I'm just going to declare a variable. I'll call it double max. I'm going to initialize this maximum variable to be my first element. So I'm going to use my 0th element as our initial maximum. This way, I can compare all the later values in my array to that very first maximum value. So basically, inside my nested for loops, I just need to check whether the next element is the new maximum. So here I just need an if statement. If input array or input 2D array element row element column is greater than my current maximum, if I'm larger than my current maximum, then I set my maximum to be that new maximum value. So if I discover that the next element is greater than our current maximum, that element becomes our new maximum. We don't need to do any more cout statements here since we're not outputting. The last step is this function needs to return our maximum value back to main. So we have to add that return statement so that once we've found our maximum value, we return it. To help us test our function, let's go ahead and add another line of code in here. Let's add a line of code that will call findMax. That way, we can check whether we did this correctly. So now we have findMax in there. Our last function to write is makeEven. Let's go ahead and write this one real quick. MakeEven is a little bit different than some of the functions we've done. Basically, what we need to do is check each element inside my input 2D array. And if that element is odd, then we add 1 to the element to make it even. That's all there is to it. So basically, we just need to check whether the next element is odd. To do that, we just use our modulus operator. If our element modulus 2 is 1, or we can even say that just not even, right? Either way. So we could also say if input array element row column modulo 2 is not equal to 0, then what do? Then we add 1 to that value. And we got an error here. And notice we do have a Notice we do have a item here where modulus can actually only accept int type arguments. So here we'll actually need to do static cast. Let's cast input to the array row column as an int. So we're going to temporarily read our current element as an integer so that we can perform the modulus and check whether we are even or odd. So here, if we are not even, we must be odd, then we add 1 to that element. That's actually all this function needs to do. And remember, we needed static cast because modulus requires an int input. So we just had to temporarily cast our input array. Instead of being a double, we had to read it as an int for that modulus calculation. Now that we've written that definition, let's go ahead and try running it. So we'll add some function calls, now calling make even. And if we do that, let's go ahead and call make even using my 2D array and rows, just like with our other functions. And then we'll call print 2D array one more time in order to output the array after we have done make even. We've finished our function definitions, so let's go ahead and test these out. Ah, look what happens. Did you see that? We correctly determined our max value is 10. I forgot another new line here, but you can see that after we determined our max value was 10, we call make even, and look what happened. Make even added 1 to all the odd numbers, and when we outputted our array the second time, we see that all the numbers in our array are now even. So playing with functions like this is really good practice. I highly recommend that you try going back through this program yourself and verify that you can code up these same functions and get the same result. For more practice, you could try adding additional features. See if you could set all the perimeter elements to 0, or maybe find the average of all the odd-numbered elements only, or find the sum of all the elements excluding a certain range. By playing around with arrays and functions like this, you'll be able to develop your coding intuition and get really good at writing for loops and functions with arrays. All right, let's now try our next example. This is a pointer question. And for these types of questions, it's very helpful to draw pictures as you complete these questions. This will help you keep track of what's happening in the memory. In this example, we are given some information about where the variables are stored. Our task is to determine the output of these cout statements at the bottom of our program. So in this case, I highly recommend that you draw pictures. And the convention I like to follow is putting the variable name on the left-hand side of its box. I like to put the memory address on top of the box. And I like to put the value inside the box. If this variable is a pointer, I can make it point at other things by drawing an arrow. So let's go ahead and read through this program line by line, and we can draw pictures to help us track what is happening. So first, we declare our variable v1. So I'm going to go ahead and draw a box for my variable v1. So name is v1. We're told v1 is stored at address 1000. And v1 currently is initialized to hold the value 3. Next, we declare v2. I give it a box. And v2 is stored, we're told, at address 1004. And v2 currently is initialized to 1. Next, we are declaring 3 pointers, p1, p2, and p3. I'm going to remind myself that they're pointers by putting a little asterisk in front of the name. And give each of them a box. p1 is stored at 1008, p2 at 1012, and p3 at address 1016. We are told that p1 is initialized to point at v1. So p1 is holding the memory address of v1. So that means the value stored inside p1 is the memory address where v1 lives. So in this case, since p1 holds the memory address of v1, we say p1 points at v1. Similarly, p2 is currently holding the memory address of v2, which is 1004. So that means p2 currently points to v2. And finally, p3 is currently initialized to 0, so this one is currently pointing at the null memory address, or null pointer. So now we've initialized all our variables. Let's go ahead and read through the rest of our program and track what is happening. First, we have this line p3 equals new int. So now, instead of pointing at null, p3 is pointing at a new int. In the next line, we write asterisk p3 equals asterisk p1 plus asterisk p2. Remember, if we use asterisk, that means that we are accessing the data that that pointer is pointing at. So asterisk p1 is going to return the value p1 points at. p1 is currently pointing at number 3, so asterisk p1 is 3. Asterisk p2 is 1 because p2 is currently pointing at 1. So here, asterisk p3 is going to be equal to 4. That means we're going to go where p3 points and set that data to hold 4. Therefore, our new int is now going to hold the value 4. So we completed that second line. In our third line, we say p1 equals p3. So essentially what's happening here is p1 is now going to store the memory address of our new int. We weren't given that memory address, but we know if we set p1 equal to P3, we know that that means P1 and P3 must now both be pointing at the same memory address. Now we're on the fourth line. Asterisk P2 equals asterisk P1 times 2. Well, what's asterisk P1? Asterisk P1 is the value P1 points at. P1 is now pointing at 4. So here we're going to say asterisk P2 equals asterisk P1, or 4, times 2, which is 8. So what that means is we're going to have to go where P2 points, and we're going to change that value to 8. Lastly, in our line 5, we have V1 equals asterisk P3. So V1 is currently initialized to 3, but we want to change V1 to hold the value that P3 points at. So this is going to change to 4. So finally, in our last line of code, we have V2 equals asterisk P2. Well, in this case, P2 is already pointing at V2. So here, we would just be updating V2 to be the value 8. But in this case, V2 already holds the value 8, so we're good to go. So finally, our last task is to go through and update what these cout statements will output. So all we need to do is look back at our picture and determine V1, ampersand V1, V2, and ampersand V2. So here, variable V1 currently holds the value 4 based on our figure. And we know that V1 is currently stored at address 1000. We also know variable V2 now holds the value 8, and V2 is stored at address 1004. So there you have it. Notice how drawing pictures can really help keep track of what's happening in these programs. This was just a simple example, but if you remember from our more complex examples we've done, drawing pictures really helps. So I highly recommend you go back through and practice this example and our other examples like it until you get comfortable. Another thing you can do if you'd like additional practice is you can try putting these pointer example programs directly into CLion. And you can actually see where the initial memory addresses are, and you can actually check the output from CLion directly to see what we get. And in this case, you can see that we were able to arrive at the correct answer. And we see, in this case, just instead of having 1000 and 1004, we had hexadecimal numbers for our memory addresses. All right, let's go ahead and try another pointer example. In this example, our task once again is to find the output for the cout statements shown in the program below. We are also given the initial memory addresses where some of our variables are stored. Once again, remember to draw pictures as you solve problems like this. The approach I recommend is writing the variable's name, address, and value in boxes like this. And then as you read the code, you can track what is happening. Let's go ahead and try this example. you'll notice we have a mystery function and our main function. We always start running in our main function first. We don't go into our mystery function until we call mystery from main. Also, please note that since we have two functions, we're going to have two separate sets of variables. We're going to have variables that are local only to our main function, like x, y, and z. And then we're going to have variables a, b, and c that exist only in our mystery function. So it's a good idea to kind of separate out your variables in main and in mystery while solving this question. Let's go ahead and start in our main function and go through this program line by line. We'll draw our pictures and keep track of what's happening. So in main, you see we first declare the variables x, y, and z. And we also have a variable named result. We are also given memory addresses, so we have address 1000 for x, 1004 for y, and 1008 for z. Result is at 1012. So I'm just updating the names and addresses based on what we're given. We're also told x initially is set to 1, y is 2, z is 3. The value of result will be whatever is returned when we call the mystery function. So now that we're about to call mystery, let's jump into the mystery function. And inside the mystery function, we have variables a, b, and c. We are given a is stored at the address 2000, b is stored at address 2004, and c is stored at address 2008. Notice we are substituting in our value x in for a in mystery. And notice the ampersand here. This is passed by reference. So what that means is that when I plug in my value x in to my mystery function main, this is done with pass by reference. So changes made in mystery also change x in main. So in this case, I'm plugging in my value x for a in mystery, but if I change that x, if I change a in mystery, it will also change my value in main. For my second argument of mystery, I'm plugging in ampersand y. So I'm plugging in for value b, I'm plugging in memory address of y, which is 1004. Since b is a pointer, that means that this value b is actually going to be a pointer, which points back at my variable y. Finally, I'm plugging in the value z, which is 3, plugging that in for c. Notice there's no pass by reference, no pointer here, so I'm just plugging in a copy of z into my variable c. Let's now run the code in our mystery function. First, we have a++. Well, that's going to take my value a. That's the same as writing a equals a plus 1. So this is going to become 2. And since we're passed by reference, x back in main also becomes 2. Next line of code, c minus equals 3. That's the same as writing c equals c minus 3. Well, we're going to take our value 3. Now c is 0. Because 3 minus 0, or 3 minus 3 is equal to 0. Finally, last one. Asterisk b, asterisk equals 2. So here, I'm writing asterisk b equals asterisk b times 2. So I'm going to go where b points, that's this value 2. I'm going to multiply that value by 2, and then update such that b is now pointing at the data, which has been updated to hold 4. So I go where b points, and I'm doubling that value. Alright, that is it for my code inside Mystery. Finally, I need to return a times c. So my value a holds 2, value c is 0, 2 times 0 is 0. So I'm returning 0 back into main. That 0 is going to be put inside result. Finally, I have finished running all my code. It's time to do my cout statements. First, I output x. X holds the value 2. Next, I output y. Y now holds the value 4. Z will hold the value 3, as we determined, and result will hold the value 0. So there you have it. Notice how helpful it was to draw these pictures to keep track of what was happening. If you have questions like this on our exam or in future assignments, make sure you draw pictures to help keep track of what's happening. If you'd like more practice, check out our other pointer examples. And for even more practice, you can also try putting this code in CLion itself. And you'll see that if you were to run this code in CLion, you would indeed get 2430 as your output. Let's now continue with a short example on dynamic arrays. In this example, we want to declare some global constants and a dynamic array of double type. Then we want to initialize the elements in our dynamic array to be the sum of our row and column index. We'll output those values to the screen. And finally, we will delete the contents of our dynamic array. Let's take a look at how we will do this. All right, so here we are in CLion. Let's go ahead and code up this example program from scratch. So we need our include IO stream using namespace standard, and we need our main function. We also want to declare some global constants, so let's go ahead and just put those before main. We want rows to be 4, and we want calls to be 5. So we went ahead and declared those global constants. Next, we want to declare that double type pointer and make it point to a dynamic 2D array. So let's go ahead and do that. So we'll say double star myPtr. That will declare my double type pointer. And remember, if we want to make the 2D array there's actually two steps. I need to first make my PTR point to an array, to a 1D array of double star pointers, then use a for loop to make each pointer in that 1D array point to a 1D dynamic array of doubles. So actually in this case, we need to have our double type pointer myPtr. It's actually going to have to be double star star because we want this to be able to point to a double type pointer address. So here we go ahead and say my pointer points to a new double. But notice here we want to point to a 1D array of double pointers. So this array needs to have the same amount of elements as our number of columns. So here we're going to make the myPtr point to 1D array of double star pointers. And then next we can use a for loop. And inside this for loop, we're going to make each of those pointers point. Make each pointer in the array point to a 1D array of rows doubles. So this will allow us to build our array one column at a time. So here we can go ahead and say that in this case, it will be myPtr element I is going to point to a new double with rows elements. And now that we've done that, myPtr will now point. myPtr now points to a 2D dynamic array of doubles. So now we want to go ahead and output this array to the screen, and we want to be able to initialize each value in that array. So let's use for loops and myPtr to initialize each element. We're told that we want to initialize each element to be the sum of our row and column index. So we can do nested for loops. So we go through each row and each column, and notice all we need to do is use myPtr and our square brackets to access each element. And here, we want to initialize each element to be the row index plus the column index. And we can also, in the same loop, we can also output that value to the screen. And I'll go ahead and separate the values by a tab. And we can put a new line after we have outputted each row. So now we have initialized each element and outputted the element to the screen. Finally, the last thing we needed this program to do was to use the delete operator to delete the contents. So you'll remember when we use the delete operator for a 2D dynamic array, we first have to delete each column, and then we delete the dynamic array of double pointers. So the code will look something like this. So for each row, here we are deleting the column where each row's pointer points. And then once we have finished that for loop, we exit our for loop and we delete and of course here we need to use square brackets again. This will delete the 1D array of double pointers. So it's a little bit involved to delete the dynamic array, but if you just remember to first basically go in reverse order, first delete the things in each column, so delete the first array here where we made each pointer point to a new double, then we delete the original array of double pointers. So you basically delete in the opposite order that you declared everything. All right, so with that, let's go ahead and run this code and verify that we're able to get the desired result. And so as you can see, we were able to successfully create our array, which has 4 rows and 5 columns. And each value was initialized to be the sum of the row index plus the column index. And we were able to delete the values when we were finished. All right, in our last example, we are practicing using structs. And in this example, our task is to complete function definitions for the getImageData function and the output PpmData2File function so that our main function here will run. So you can see we've been provided with declarations for these functions. getImageData is supposed to prompt the user for data for a PpmImage struct. So it will ask the user to input all the data needed to initialize this PpmImage struct. Notice this PpmImage also contains a pixel struct, where each pixel struct contains RGB values corresponding to a pixel. If you need a review on PpmImages, definitely check out our prior videos on applications of arrays. And that includes a basic explanation of how PpmImages work. So our first function is designed to initialize a PpmImage struct. And the second function should take that PpmImage struct and output all the data in that struct to a data file. Let's go ahead and give this a try. So here we have our PpmImage struct, and initially I have these max rows and max columns set to a large number, but for my testing, I'm going to go ahead and set it to a lower number initially, just so it's easier for us to test. We've declared a pixel struct, which holds int values corresponding to a red, green, blue pixel. We've also declared a second struct for a PpmImage, where the PpmImage has a magic number, such as p3, a width and a height, a maximum pixel value, and notice we have an array of pixels, where each of these pixels contains an RGB value. So our goal for the first getImageData function is to write a function which will initialize a PpmImage struct to the data supplied by the user. So we need to use cin and cout in order to prompt the user for the PpmImage data. Then in our second function, output ppm data to file, we need to take that PpmImage that has been initialized and use our file stream objects to output that data back to a file. Notice in both of these functions, we're going to need to use the dot operator to access data inside our struct. Let's start with our getImageData function. So I'm going to go ahead and start writing the definition after my main function. And just to help me remember, I'm going to temporarily paste my struct definition here. I'm going to temporarily paste my struct variables here just so I remember what the things are that I need to initialize. Notice this getImageData needs to return a ppm type struct. So the first thing I need to do is declare a PpmImage to hold the data from the user. So I'm going to go ahead and declare a PpmImage variable named newImage. That's going to hold all my data, and then I'll return this initialized PpmImage struct back to main. So first we got to prompt the user for the p1 value, or for the magic number. So we need to ask the user, what magic number do you want us to give? And the user is going to input the magic number to the screen. We want to store this magic number in newImage's magic number value. So we use the dot operator to store whatever input the user gives inside newImage.magicNumber. Remember, the dot operator allows us to access each of the member variables inside our ppm struct. Next, we need to ask the user for the width and height. So I'm just going to borrow my code that I just wrote and update those. And also I need to ask my user for the maximum value. Or in this case, it's called max pixel. Typically that one is set to 255. It's the maximum value our pixels can be. And lastly, we need to use our width and height, and we need to initialize image pixels. This is the array that holds all the pixels in our image. So notice in this case, remember, we should not use max rows and max cols for this calculation. We should instead use rows and cols from the user as the number of rows and columns in the array. Because there's no guarantee that our image is always going to be the maximum size. It could be smaller, so we want to make sure we use, in this case, our width and height provided by the user. So in this case, we'll go ahead and use width or in this case, we'll go ahead and use height as our number of rows. And we'll go ahead and use our width as the number of columns. But notice here, I can't just use height like this. I need to use the dot operator here. So I need to say new image.width and new image.height. Because I want to specifically use the width and height in my image. So here it becomes a little bit more complex because now we need to ask the user for the RGB pixel values at each pixel. All right, so let's go ahead and prompt the user. Enter the R value for the pixel at row I and column J. So here we're asking the user for the R value, so we're going to go ahead and say cin, and notice here we need to access image pixels, and we need to access rval inside that pixel. So we're going to take new image dot image pixels to access our array element ij, but then I also need to access the red value inside the pixel struct, so I have to do this. I have to use the dot operator twice because I want to go into new images image pixels array, and within that pixel struct I need to access the red value. Similarly, I need to do the same thing for the green value. So we need to enter the G value for the pixel. And then finally, we need to enter the B value. So that will allow us to go through each pixel in the array and get a red, green, and blue value. But notice this loop will allow us to go through and access all the pixels in our struct and correctly update the values based on the user's specifications. So this function will allow us to get our image data for that image. Once we have initialized all the things in our struct, so we have initialized everything here, then we will be able to return our new image struct back into our main function. So notice how powerful that is. It's almost another way of making it possible for a function to return an array. So if we have a struct that contains an array, we can still return that if our function is able to return the struct type of data. All right, so we wrote our first function for getImageData. Let's now write our second function. And remember, our second function is output ppm data to file. Notice this function is going to take the name of an existing ppm image, so it's PpmImage struct, and the name of an output file. Then we're going to write all of our PpmImage data to that output file. So let's go ahead and update this function header here. And let's go ahead and we'll just delete this old code from our copied extra function. Here we're going to do some file manipulation. Since we want to write to an output file, we need to use our output file stream object. So we declare our output file stream object. And notice we can open our output file. Oops, and I typed incorrectly. Here this should be outfile.open. So we want to open output file name and use that as where we write all our PpmImage data. Now our task is to go through and write all the data in our PpmImage to our output file. And we want to use the same format that we covered in our sample programs. So we want to start with magic number. But remember, we can't just go output file magic number like this. That won't work. We have to output image.magicNumber because we need to use the dot operator in order to access that data. On the next line of our ppm file, we want to output our width and our height. So we'll output those separated by a space and put them on their own line. Then we output our max pixel. So here, remember, we output using the dot operator. And now we need to use for loops to output each pixel, including the R, G, and B values, to the ppm file. We're actually going to use a very similar loop to the one that we wrote here. So I'm going to go ahead and borrow this loop again. In this case, we now want to read through our ppm struct named image, and we want to go through each pixel of that image, so we go through the height and the width, and we need to output the red, green, and blue pixels at each location. So in this case, for each element I, j, we need to go through and output the RGB value. So here we'll go ahead and use outFile, and we'll output our red first. So remember, to access our red pixel, that will be image.imagePixels ij. But then we also have to say .rval in order to access the red value. Here I'll go ahead and put a space between each of these. And notice I need to continue this same out file statement. So I'm going to go ahead and repeat it for a G value. And finally, for my blue value, B value. And I would like to have, just for nice formatting, I want to have a new line after each row. So I'm going to also use outFile with a new line so that each row of pixels is outputted on its own line. But notice that's all we need to do. Once that loop is finished, we could just output a message to the screen if we wanted, but we already have a message back in our main function, which tells us our image has been written to the file. So let's go ahead and try running this program, and let's verify whether we were able to successfully read and write our PpmImage. All right, so here we go. First, this program's main function has called our getImageData function. So first thing we did, we've called getImageData. So now we need to enter our data. Say magic number P3, maybe our width and our height are both 2. Let's say our max pixel value is 255. And we can go ahead and start entering pixel values. So I went ahead and entered the pixel values. Now I need to enter the name where this image's data file should be written. I'll go ahead and just call it output.ppm. And the program has run. And if we look inside, we see that we were able to successfully generate output.ppm. I can open it in Explorer. Let's see if we were able to make our image. So notice if I open this in Irfan view, I can fit my image to window, and I can verify that I was able to generate the RGB image that I wanted. And notice that my output file does indeed contain all the data that I had stored in my struct. So once again, if you'd like more information about PpmImages, be sure to check out our previous video on applications of arrays. Alright, so this concludes our example of using the PpmImage struct to manipulate PpmImage data. Thanks everyone for watching these videos, and I hope you found these examples helpful. Feel free to reach out if you have any other questions, and we'll see you in the next video.